everyone, I hope you're doing great tonight. So my name's Maggie and I'm going over a couple physics problems. Now this is for like intro to physics, physics 1 mainly because we're just dealing with vectors. This is a trig video, so if you're looking for calculus, I'm sorry, can't help you right now. That's not what I'm focused on. But anyway, so we're going to work on a couple of these problems, and this is actually from a homework that was submitted to me with a couple questions. So we're going to do number 6 right now. We're going to start with that one. Everything's going to be color-coded so we can kind of figure out what's going on, because if not, I'll get really confused, and then I'll confuse all of you. So anyway, here's the question, and I kind of summarized them a little bit too. So during a rodeo, a clown runs 8.0 meters north, turns 55 degrees north of east, runs 3.5 meters. Then, bunch of text, the clown runs due east and runs 5.0 meters to exit the arena. So what's the clown's total displacement? So, sorry about that. So total displacement is not actually adding 8.0 plus 3.5 plus 5.0, because if it was, you guys wouldn't be here for the video. But anyway, so we're going to go through and we're going to work this out ourselves. So over here on my left side of the screen, I'm going to draw this diagram. So let's see, he runs 8.0 meters north, and this is map to size. So that's 8.0 meters north, and now we're going to run 3.5 meters north of east. So I'm going to make a little coordinate section right here, because right here is where he changes direction. So right there, this is X, and this, whoops, I'll just do this, and this is Y, X, there we go. Ooh, that's messy, it's fine. So he changes. So since he's going north of east, we're going to travel north, and then we're going to travel east. So that means he starts here. Oops, where are we? There we go. Nope. I forgot to change the thickness. There we go. So he travels east, and then he goes up 55 degrees north, and he does that for 3.5 meters. Now he's going to change direction again. We're going to do this one in green. And he goes directly due east for 5 meters. Yeah, we're going to say that's definitely 5 meters. So there we go. Now, pardon my handwriting because I'm using a mouse to do this. So, where'd you go, mouse? Okay. So right here, you know what? I will text it. Right here, this is 8.0 meters. This needs to be red, and we'll pull it. And right here is 3.5 meters, and this is blue. And this one right here is 5.0 meters, and we'll make that one green. Okay, now we're gonna go back. And this is where it gets a little tricky. I'm going to go ahead and draw in the angle, okay? And my angle's going to be another color of the blue, because that's what I do. Okay, we're going to pretend that that is the most beautiful arc you have ever seen. You know what, let's make that a little thicker so you can actually see it. So, whoo, there we go. And this angle is 55 degrees. Now remember, this angle is measured from this axis here up. Don't forget that. So we've got our diagram set up, in this brown line right here. This is what we're trying to figure out. If my mouse will, there we go. This right here is what we want to know, because that is your displacement total, okay? So we're going to go over here. For the first portion, we're doing that again in red. Oops. In red. So the first portion over here is in the X and Y value. Now, since our wonderful little clown just went a directly north, he does not have an x value displacement, so we're going to leave that at 0. The y, since he went directly north, we don't have to do any trig. He went exactly 8 meters north. Okay? Now once we get into here, the second part of the question, that's where it gets a little tricky. So we're going to leave these two open so I don't forget what they are. And we're going to use some trig identities. So whenever I was in high school, I guess grade school, we learned it as SOHCAHTOA. SOHCAHTOA. So, sorry, I made myself giggle. SOHCAHTOA, so, opposite over adjacent. So, it would be opposite over hypotenuse. I'm sorry, hypotenuse. And then ka, which is cosine, is adjacent over hypotenuse, and that gives you the degrees. So what we're gonna do, or see if we can do is, we are going to zoom in here so we can just focus on this beautiful thing right here. That made my picture really, really ugly. I'm sorry. It's okay. So we are going to pretend that this here is a whole triangle, okay? So going back out here, we'll choose this color. So this here is our angle, right? So this line here is adjacent to our angle. So that's adjacent. This is our hypotenuse because it's the longest one. And then this is our opposite side because it's opposite of the angle. So keep that in mind. So we need to figure out the x and the y. So remember, this is the x. So the adjacent value here is in the x direction. This opposite value here is in the y direction. Okay? So we figure out what's corresponding. So we're trying to find this y direction first. So a little bit of algebra, and the opposite value, or the opposite side, equals the hypotenuse times sine of the degree. And then that'll be same for over here. Your adjacent angle, or side, is the hypotenuse times the cosine of the degree. Okay? Don't ever forget that. So we're going to pull up our handy dandy little calculator right here. I'll scroll down a little bit so you can see it. So we're trying to find the opposite right now, okay? So the opposite of the 55 degrees is the sine value. So we're going to type in 3.5, and I'll show up right here, 3.5 times the sine value, and then our degree, which is 55 degrees, 55 equals, and then this is our y value. So we just found our y value, and that y value, come on, is 2.8, and then we'll round up, so it'll be 2.87 meters. And that's our y direction. So we can go ahead and put that right down here. 2.87 plus, because remember that entire point starts from here. So it's plus 8. So we'll go ahead and just add that. 2.87 plus 8 equals, so the max height here is 10.87 meters. Now we're going to go ahead and we're going to do the x value. So that is this adjacent value. So you want to look for the one with the a in it. So it's this one right here. So a equals hypotenuse times cosine of the degree. So I'm going to go through and I'm going to clear my calculator. So remember, 3.5 times the cosine of the degree, so 55, equals, and then that's 2.0075. We're just going to cut it off and round it here, 2.0. And since it started from x equals 0, moving all the way over, this right here, this is 2.0. So we got our x value, 2.0 meters. Okay, awesome. Now the next one, the next part of this question, woo, not that far out. The next part of our question handles right here, the 5.0 meters, okay? So we're going to go through and see how much of this I can undo. Get rid of that nasty circle. There we go. Okay. So we just found that this x value right here, x equals 2.0 meters. Don't ever forget your units. A good physics teacher will yell at you for your units. And then the total y value here, because remember it's this entire distance. See this one right here. Oops. This entire y distance right here is 8.0 plus, what did I say it was? 2.87 equals 10.87 meters. Okay, awesome. Now we need to figure out at, oops, this endpoint. Oopsie. My bad, guys. I'm making all kinds of mistakes tonight. At this point right here, what's this x value? Because it goes all the way back here. So it's your x total. Sorry, and this here is your y total, because that's the max height it gets to. And this is the max distance. So we can just add this x value to this value because it's in a straight line, okay? So it's 2.0 plus 5.0, and that gives us 7. So I did this color. What color did I give you? Oh, I made you green. So here we go. It is, what did I say? 7.0 meters, comma, y total, because it stays this height all the way through, 10.87 meters. Okay, so what we're going to do now is we're done with these trig identities, and we're going to use another formula. So what it is to find d total, this is, come here, there we go, h equals the square root of x squared plus y squared. There we go. Awesome. So we're going to take that over into our nifty little calculator, and it's going to be, let's see, square root, and our x value, gotta scroll a lot. There we go. I'll put that down there. Our x value is 7.0 squared plus, and then our y value, which is 10.87 squared, because it's the max distance at this point right here, and since this starts at what we call the origin, it gives you the actual distance of your hypotenuse. So we're going to hit enter, and our value is 12.92. So we just found out that our h value, also known as our displacement total for this video is 12.9, and we'll just go ahead and round it up to 3 because it's 2.8. So it's 12.93 meters. Okay, now that right there is question 6. So your D total is 12.93 meters. So I hope you guys enjoyed that, and it was at least a little clear. This is my first video, so we're going to see how these go. This was question 6. I'm going to be uploading 2 more questions regarding questions 7 and 9 here in a little bit. But this is question 6, and let me know down in the comments if it helped you out. Thank you guys, and I'll see you in the next video. Bye-bye.